All right, this is the chapter 2 practice test. So this test has 20 questions on it. We're going to get probably the first 10 done in class today. So number one, first thing we did this chapter 2, is we converted fractions to decimals and decimals to fractions. And so we have a mixed number here for number 1, 4 2/5 that we need to write as a decimal. So first of all, if there's a number in front of your fraction, number 4 in this case, that number is just going to go in front of the decimal. So there's really nothing I have to do with the 4 other than just rewrite it in front. It'll be 4 point something, right? The fraction that's in question here is 2/5. Now, during success time last week, we looked at some popular fraction decimal conversions. 2/5 was on there. Does anyone remember what 2/5 is as a decimal? Gavin? 4/10, which means 0.4. So 2/5 or 4/10 is the same as 0.4. If you have that memorized, then this problem is really easy for you to do. 4.4. 4 2/5 is the same as 4.4. And that's all you need to write on your work paper. 4 2/5 equals 4.4. How many of you had 2/5 memorized? Okay, so a little under half the class. So if you don't have your fifths memorized, you could study the worksheet that we did or the notes that we did last week over that. There was the fifths, the fourths were also on there, and your tenths, your eighths, and some popular fractions. Or you could do what everybody else has to do, which is to turn a fraction into a decimal, do long division. Top divided by bottom. Top number divided by the bottom number. It's important that you put the number in the right spot, which means 2 would go inside the division box and 5 would go on the outside. Now, does 5 go into 2? Of course not. Yeah, of course not. So I'm going to put a decimal point, 2 decimal points, and then put a 0. And how many times does 5 go into 20? 4 times, which gives you exactly 20. And that's why we said that 2/5 was 0.4. And so that I would just attach that 0.4 onto the 4 that's already in front of my mixed number. And so I have 4.4. So if I don't have my fractions memorized, or if it's one like we had on our quiz, I think the one on our quiz 2 weeks ago, no, it was Monday last week, was I think 17/40ths. So if that's the case, we just have to do top divided by bottom. All right, let's move on to number 2. Number 2 is 13/4. Does anyone have their fourths memorized up to 13? So let's try top divided by bottom on this one. Top number goes inside the box. Bottom number goes outside the box. In this instance, the top number was larger because it's an improper fraction. So it's a division problem that looks more familiar to us. But don't freak out if the number inside the division box is smaller. More often than not, it will be. It's always the top number that goes inside, regardless if it's bigger or smaller. How many times does 4 go into 13, Hugo? 3 times. All right. What is 4 times 3?
12.
12. Subtract, get a difference of 1. So because it's not a remainder of 0, I have to put a decimal point. And I drop down to 0. How many times does 4 go into 10? Anybody? You can just say it. Just shout it. We'll do it twice, right? 2. I was going to say this is a class review. Goes in twice. 4 times 2 is 8. I subtract and get a difference of 2. So I drop down another 0. 4 goes into 20 5 times. That's going to give me exactly 20. Get that remainder of 0. So 13/4 is the same as 3.25. Now, another way you could do that problem. How many of you think you know your fourths? Okay, quite a few of you. Another way you could do this problem is by converting this improper fraction into a mixed number. So Hugo told us that 4 went into 13 3 times. That's 12, so you have 1 left over. 13/4 is the same as 3 1/4. And if you know that 1/4 is 0.25, as a lot of you said that you probably remember that one, then this problem became really simple for you and didn't require any long division. Sometimes what I do with improper fractions if I peek at the denominator, and it's a denominator that I had memorized, like my fourths, I'll just write it as a mixed number, because 3 1/4 is just 3.25. You go. Sure. All right, let's look at number 3. For number 3, they're having us write this decimal as a fraction in simplest form. Now, what does it mean to write a fraction in simplest form? Draven? Logan? You have to reduce it. Yeah, it's got to be reduced. It can't reduce anymore, right? So it's got to be in simplest form. So that's exactly what that means. So I know that it's negative. A negative decimal is going to give me a negative fraction. And then to write my fraction, I take the 34 that comes after the decimal point, and do I put it on top or bottom of the fraction? Top. On the bottom is going to be a 1 followed by a certain number of zeros. Meaning it's either going to be 10 or 100 or 1,000 or 10,000. It's over 100. Yeah, it just depends on what my decimal place is. So I got the 10ths column and I got the 100ths column. Because it has 2 decimal places, I'm going to put 2 zeros after the 1. If I had 3 decimal places, I put 3 zeros after the 1. And so this is negative 34 over 100. Luke, you have a question? Yes. Now, if you try typing this in on formative, like you will in your chapter 2 review, it would say that it's wrong. Because as Logan said, it's not reduced. So to reduce it, we have to think of a number that goes into 34 that also goes into 100. Isaiah, can you think of one? 2. Thanks, Alan. We are on number 3 right now, and you can watch this video to take the first two. All right, so Isaiah, what's half of 34? 17. And half of 100? 50. Now, can you think of a number that goes into 17 that also goes into 50? No, so it must be reduced then, and that's correct. 17 goes into 17, but 17 is not going into 50 evenly. So our answer is now reduced. Negative 0.34 or negative 34 over 100 reduces to negative 17/50. And that's how you turn a decimal into a reduced fraction. I prefer doing this. Now, I'm not a big fan of reducing. I don't like, that's why I cancel so much when I multiply. But I think it's easier than having to do the long division. Especially, now this is one that I could have memorized. So that one would have been easier had we just converted to 3 1/4 to begin with. But I think this is easier because you're always taking the number that comes after the decimal point and writing it on top of the fraction, and always putting a 10 or 100 or 1,000 on bottom of the fraction. Number 4. Number 4 wants us to graph each number on the number line. Now, I'm not going to make you draw a number line on your paper. Essentially, what they want you to do is to order them from least to greatest, which is what we can do, even without a number line. So we're going to order them from least to greatest. But you'll notice this number line is all in decimal form. That's how you should write your answers or write these numbers so you can compare them. It's easier to compare numbers when they're in decimal form versus when they're in fraction form with different denominators. So let's start with 11/5. We have to convert that to a decimal. So this is number 4. What if instead of doing long division, we started to first write it as a mixed number? How many times does 5 go into 11? Twice, with how many left over? Okay. Now, how many of you know your fifths off your head? Miley, what is 1/5 then? 2.2. 0.2. Exactly. So this would be 2.2. You're exactly right. This would be 2.2. That's the advantage to knowing your fifths, right? To knowing some of those fractions is that you don't have to do long division. Otherwise, you're doing 11 divided by 5, and you'll get 2.2. Don't worry, you'll still get that. Okay. The next one we have is 2 3/5, which of course is also going to have a 2 in front. And does anyone know what 3/5 is? Olivia? 0.6. Exactly. Your fifths are 1/5 is 0.2, 2/5 is 0.4, 3/5 is 0.6, and 4/5 is 0.8. And that was on that list of fractions that we did last week. The last one's already in decimal form. So if I was doing this on big ideas, I would then have to line these up. I would drag them up above the decimal, the number line above the decimal they represent. But all that you need to do is to write them in from least to greatest and maybe just put a comma to separate them. So which of these is the smallest? We'll start with the least. Which one, Logan? 2.2. Yeah, so 2.2 would go right here. And Big Ideas called it 11/5, but it's the same thing. You could put 2.2 or 11/5. And after 2.2 comes what? Hugo? 2.4, which was already in decimal form. So I didn't have to do any extra work for it. So 2.4 goes right there. And that leaves the last one, which is 2.6, or 2 3/5, to go right here. 2.2, 2.4, 2.6. Yes. Number 5. Now we're going to get into adding, and this is a fraction problem, so adding fractions. Now, is it necessary that I find a common denominator when I'm adding or subtracting with fractions?
Yeah.
Yeah, it is. Yeah, unfortunately, yeah. We don't have to find a common denominator when we're multiplying or dividing, but when we're adding or subtracting, we do. So when trying to find a common denominator, start with the smallest denominator that you see up there, which is the 5. Is there a number you can multiply 5 by to make it into 10? Of course. What is that number, Olivia? 2. Sometimes you only have to change one of the fractions instead of both. This will give us -2 tenths. We don't have to change the second fraction. We can leave it as 17 tenths. All right, now we have to think back to what we did in chapter 1 with integers, positive and negative numbers when adding and subtracting. I've got an addition problem, which means I'm either going to join forces or do addition wars. Am I joining forces or going to war, Gavin? Yes, we're going to war, which means we have to subtract here. Which army wins the war, Gavin? Positive army wins by how many? 15, and there's the subtraction, 17 minus 2. So positive 15 tenths. Now, this answer is correct, but it is not in simplest form. What number goes into 15 that also goes into 10, Mason? 5, exactly. So we can divide the top by 5, divide the bottom by 5, and what will this reduce to then, Mason? 3 halves. Which I am perfectly fine with that answer. So I'd give you full credit on that. I'd give you partial credit. I'd probably give you half credit on that answer because it's right, it's not reduced. I'd give you full credit on 3 halves. For those of you that would want to write it as a mixed number, I would also give you full credit on that as well. 2 goes into 3 once with 1 left over. 3 halves is the same as 2 1/2. And so I give you full credit with that answer as well. Nope. Good try. All right, number 6. Number 6 has us adding with decimals. Do I have to line up the decimal point when I'm adding and subtracting? Again, yes, I do. Before I write the numbers down, though, can you tell me if I'm actually going to be adding or am I going to be going to war and subtracting? We're going to war. Again, yeah, the signs are different, so we're going to go to war. And when we go to war, the larger army wins and the larger army gets written on top. So 7.63 is going to go on top. Line up your decimal points, 5.24. I think you probably would have lined up your decimal points regardless, because there's no extra digits. So there's no zeros that I have to add here. We said we're going to war, which means we subtract. Also, which army won? Negative. So my answer is going to be negative. So I have to put the 7.63 on top in order to do the subtraction. Can't do 3 minus 4, so let's do this one together as a class. Borrow from the 6, make it a 5. What is 13 minus 4? 9. What is 5 minus 2? 3. Drop down your decimal point. And what is 7 minus 5? 2. So the answer is negative. Negative army wins. Negative 2.39. When it comes to adding or subtracting, I prefer decimals over fractions, for sure. When it comes to multiplying and dividing, I prefer fractions over decimals. So I think the fractions are less work when you multiply and divide. Number 7. Number 7's got some multiple steps to it here. Am I going too fast? Is everyone able to get number 6 written down? Number 7 says negative 3x plus 5y. Evaluate it when x is a 6 and y is a 4. Before I plug anything in, can you tell me what negative 3 is doing to x right now? Multiplying. Can you tell me what 5 is doing to y? Also multiplying. So when I plug in 1/6 for x, it doesn't become negative 3 and a 6. It says negative 3 times a 6. And so the way that I can represent that is I can put the 1/6 in parentheses to show that it's not 3 and a 6. I'm actually multiplying. Or you can put a multiplication symbol if you want to. Plus 5 times y, and y is 1/4. Now, what would order of operations have us do first? The multiplication or the addition? Multiplication from left to right. So let's start with 3 and a 6. When I'm multiplying fractions, I first of all have to convert any mixed numbers or whole numbers, like these two, into fractions. Chase, do you remember how I can turn the number negative 3 into a fraction? No? What about 5? Do you remember how to turn 5 into a fraction? No? Cash, do you remember how to turn negative 3 into a fraction? Paisley, remember how to turn negative 3 into a fraction? Isabel? Put it over 1. To turn an integer into a fraction, you just put it over 1. I mean, is 5 divided by 1 still 5?
Yeah.
Yeah, so by writing 5 over 1, I haven't changed its value, but I have technically turned it into an improper fraction. Now, that could look really confusing if I'm supposed to multiply that. So if you want to, you could go ahead and just say negative 3 over 1 times 1/6, bless you, plus 5 over 1 times 1/4. That probably looks a little bit nicer for us. And as you guys said, we're going to do the multiplication from left to right first. So let's look at the first set of fractions. Is there something that cancels there?
Yes.
Austin, do you see it? If you can tell me what cancels. I find it odd that all of a sudden we all have to use the bathroom.
It's because it's class.
So,
I sometimes make this have to go to the back.
Austin, can you tell me what cancels here? That's exactly right. 3 goes to itself once and it goes into 6 twice. Once we finish the problem, you can go, okay? So on top, we've got 1 times 1, or actually negative 1 times 1. And on bottom, we've got 1 times 2. So this is just going to be negative 1/2. On this side, can the 5 and 4 cancel?
No.
No. So 5 times 1 is 5, and 1 times 4 is 4. So I've got negative 1/2 plus 5/4. So now I'm on to the second part of the problem, which is after multiplication for the addition step. And for addition, I need a common denominator. Do I have to change both fractions? No? So I can times 2 by something to get 4? Okay. What can I times 2 by? 2. Yeah. So times by 2, times by 2. Turns this problem into negative 2/4 plus 5/4. Now I've got a common denominator. Am I going to join forces or go to war? We're going to war. Which are we going to war? Positives by how many? So the answer here is 3/4. Okay. So just so you know, this might be a good time for me to pause and tell you guys anyways. I think I mentioned this earlier, but on your test Friday, if you have a fraction problem, you have to do fraction steps and get a fraction answer. Don't try converting it to a decimal and getting a decimal answer. I can't grade you on whether or not you can find a common denominator if you refuse to do it. Also, if it's a decimal problem, I'm not sure why you want to convert to fractions, but if it's a decimal problem, make sure you keep it as a decimal problem and give me a decimal answer. Use decimal rules. Okay. Austin, you can go. All right, number 8 is our next one. Number 8 is negative 5 2/3 minus 1/6. So when I'm adding or subtracting, I don't have to convert it into an improper fraction. I can leave this as a mixed number, this first one here as a mixed number, as long as I'm still finding a common denominator. Is there a number I could multiply 3 by to get 6? What is it? Also 2. Yeah. So far we've kind of lucked out with these common denominators. They haven't been very difficult to find. So this would be -5 4/6 minus 1/6. But remember what we did for subtraction last chapter. Subtraction was always keep change opposite. And so it's probably to our advantage here if we go ahead and do that, because addition wars only works if you have an addition problem. So we could keep this as -5 4/6, change it to plus, and then make this -1/6. Now it's an addition problem. Now that it's an addition problem, are we going to be joining forces or going to war? They're both negative, right? So they're going to join forces. What's joining forces mean to do? Add. What's 4/6 plus 1/6?
5.
What's 5 plus nothing? 5 plus nothing? 5. And when you join forces, do you switch teams?
No.
No. So our answer is going to be positive or negative? Negative. -5 and 5/6. That's how you would do this if you left it as a mixed number. But I know that not everybody's comfortable doing it as a mixed number. Some of you would prefer using improper fractions. And since I'm accepting improper fractions on your tests and on your homework assignments, there's no disadvantage to doing that. The numbers get a little bit bigger, but you can leave your answer as an improper fraction. So for those of you that would prefer to go ahead and let's start from scratch and to convert this into an improper fraction, that's fine. What is 3 times 5?
15.
Plus 2 more.
17.
Okay, so then you would write this down as -17/3 minus 1/6. You would still need a common denominator, and as we said, you would multiply by 2. That part didn't change. But now this is going to give you some slightly larger number. It's going to be -34/6. Also, keep change opposite, make this -1/6, just like we did for the last problem, or for the same problem, so obviously doing the same steps. And we're going to join forces again, just like we joined forces before. What's 34 and 1 make when you join forces? Yep. And you keep the same sign, so -35/6. That doesn't reduce. 5 and 7 go into 35, but 5 and 7 don't go into 6. 2 and 3 go into 6, but they don't go into 35. So that is actually the same answer. If you converted -35 into -35/6 into a mixed number, you would get -5 and 5/6. So I'm fine with either way, regardless what method you choose to use. Let's look at number 9. Number 9, decimals. I'm good with decimals when it comes to adding and subtracting. This one says subtraction, but how can I change this into an addition problem? Keep change opposite. As long as you know what you mean, right? So 8.76 minus 10.91 is the same as 8.76 plus -10.91. Change the subtraction to an addition symbol, change 10.91 into -10.91. Now that it's an addition problem, I can ask you this very important question. Are you joining forces or are you going to war? Because we'll get 2 very different answers, depending on what you said. We're going to war. Which army wins the war? Negatives. I know my answer should be negative. And this right here is also extremely important, because I saw a lot of people not do this on their quiz, and this is why they got it wrong. When you subtract, and we're going to war, so we know we're subtracting, the larger number has to go on top. And you just said the larger number was negative here. The larger army was the 10.91. So I have to put 10.91 on top, minus 8.76, and line those decimal points up. I cannot put 8.76 on top. Whatever army is the largest is also going to get written on top, so I can do the subtraction correctly. The answer is going to be negative because the larger army wins. I can't do 1 minus 6, but I can turn the 9 into an 8, and I can do 11 minus 6. That's called borrowing. Let's do this one together. What's 11 minus 6? 5. 8 minus 7? Borrow. I'm going to essentially do 10 minus 8 anyways, though. 10 minus 8 is 2, and drop down that decimal point. It is negative 2.15. And before I even do that work, those numbers, if I asked you how much the larger army won by, you'd say around 2. They won by about 2 people. Pretty close to 2, right? So I know that approximation is pretty good. Negative 2.15 is our exact answer. Let's look at number 10. Number 10 says find the distance between 3 1/4 and negative 1 3/4 on the number line. Now, I'm not going to draw a number line. I have one up here in the front of my class, though. If I asked you how far apart 2 numbers are on the number line, you could count if you actually had the number line. So, for example, 6 and 2. How far away is the 2 from the 6? 4 units. You could count, right? Start here. 1, 2, 3, 4. They're 4 units away. How else could you get 4 from the numbers 6 and 2? Subtracting them. Yeah, when you're finding the difference between 2 numbers, maybe it's 2 numbers on the number line, maybe it's 2 people's ages, 25-year-old and 21-year-old, right, are 4 years apart. You just subtract the numbers together. Now, what's important though is that we don't do 2 minus 6. We do 6 minus 2. We want to make sure we do the bigger number minus the smaller number. Can you face forward, Raven? I'm not sure what is over there that's important right now, but face forward so you're facing the board. So which of these 2 numbers here is the larger number, the positive or the negative one? Okay, so I have to put 3 1/4 first, and I'm going to subtract away negative 1 3/4. And when I use keep change opposite, this turns the problem into 3 1/4 plus 1 3/4. Again, I can turn these into improper fractions, or I can leave them as mixed numbers. I don't really care what you prefer to do, but you have to have a common denominator. What's our common denominator? Yeah, it already has 1. It's 4. So since we're adding, put 3 1/4 plus 1 3/4. What's 1 1/4 plus, or sorry, what's 1/4 plus 3/4? 4/4. What's 3 plus 1? 4. Can I write it as 4 4/4? What's 4/4 the same as?
5.
What's 4/4 the same as? 5. 1. You really need to pay attention. And so 4 4/4 would actually be rewritten correctly as just 5. Yeah. Right. So 1/4 and 3/4 gives us 1. And actually, if you wanted to, you could just not write 4/4, and you could carry the 1 like you normally do for addition and just make it 5. If you did that as improper fractions, if you change them to improper fractions, you'd be doing 13/4 plus 7/4, and you would get 20/4. And I'd say it's okay, you can leave it as an improper fraction as long as it's reduced. And so you would probably notice that 4 goes into 4 and 20, right? If not, you can probably tell that 2 goes into both. So if you divide by 4 on top, divide by 4 on the bottom, you get 5/1. And remember, 5/1 is not technically reduced. That would also give you the same answer of 5. And so using mixed numbers or improper fractions, I'm okay either way when it comes to addition or subtraction. What you're not allowed to use mixed numbers with is multiplying and dividing. And that is where we will pick up tomorrow with number 11. So put your papers away. We are halfway done. Don't lose them, or you have to write all that down later.
Good.